Alright, so here's a quick video on a Tektronix 147A NTSC test signal generator, DPS-220 frame sync, and an electronic visuals EV4061 waveform vector scope with crappy little Toshiba TV. So the phone doesn't like the color in that. There you go. So we have all sorts of different NTSC tests. They're really cool. They actually do serve a really cool purpose. So you may have seen something like that on TV. I'll just turn off the yellow on it so the color temperature goes proper on the phone. You've probably seen that on TV sometimes, in older recordings, stuff like that. Well, most likely generated by a 147A or 149A Tektronix generator. They were very popular back in the 70s and early 80s. As you know, Tektronix makes some wonderful test equipment. Usually costs a bloody fortune, so it's usually why people use it. They're very accurate. I have no idea when this thing was last calibrated. It takes about a half hour to 45 minutes to warm up before it starts generating a beautiful, beautiful picture. We have a full field test signal output on the front and on the rear. It also does a VITS insertion, which is a vertical interval test signal. So that way you can insert different test signals in the hidden vertical interval lines that are usually up top of the screen. With CRT monitors and TVs, they would need some time for the actual scanning, the line scanning on the CRT to have a chance to get back up, and that's where those vertical intervals came through. As TV technology changed, they still had that due to older TVs not wanting to change the standard, so they started inserting data. So you have closed captioning on line 21, closed captioning, say 1 and 2 are in field 1, and 3 and 4 in field 2 for line 21. It looks like this is just the standard VITS insertion. You can change it via jumpers up here. But line 17 field 1 is multiburst, 17 field 2 is noise, which you have a noise adjustment here, 18 field 1 is composite, 18 field 2 is linearity, and then you have an option to turn on these other signals through those jumpers. It gives you some insertion information if you're using it for insertion. 147A has a noise and pedestal generator. The 149A has a SMPTE bars instead of the noise and pedestal. And you also have program control, where this can actually insert into your program chain. You can select program or preview or auxiliary input, that kind of stuff, remote or local control. You can adjust the gain level here. That right now is not used because I'm not using the program input. So that's about it. Our full field text signals are as such. We have a composite. With this, I don't know what that does. I didn't look at the manual. It says Alt APL. Whatever it is, it doesn't work so well. That's what a composite signal looks like on a waveform. Vector scope, not so much. But yes, it's meant to be used with a waveform. As you can see, with our DPS-220 frame sync, I hit bypass. You'll see, for some reason, the test signal generator is outputting at a 0 IRE pedestal rather than 7.5, which is standard for NTSC. So maybe it's just old, but I think 7.5 was standard for a long time. 0 is used in Japan, NTSC. But yeah, we have a process bypass. You can change the TBC or sync options. Kind of looks cool. Changes the way it recognizes color. You can actually freeze the signal. So freeze it, unfreeze it. That's about it. For the frame sync, you have your proc amp controls here as standard. You can change our setup. Let's set up. Video level. Chroma. It changes the phase of the or not the chroma, but the subcarrier level. Sorry, that's chroma. Hue is your phase of your NTSC color subcarrier. So if you're looking at a vector scope, you see the phase changes. That's why NTSC is never the same color, because as the phase changes, say with an analog TV broadcast, your color is going to shift, and that's why you had a hue or phase adjustment. Asinine. PAL standard over in Europe, phase alternating line, is the phase changed between each line in the signal, so the color always stayed the same. It's a superior standard. Full field test signal, we have our composite signal. We can turn off our color subcarrier, which looks like this. We can change our linearity steps or ramp, but that doesn't work on composite. So we'll try linearity here now. Linearity, You have your color subcarrier, on and off. You have 5 steps, 10 steps, or a ramp. Ramp's really cool. Seems like this thing works quite well. So that's linearity. We have multi-burst, which looks like this. And no color subcarrier on that signal. And it looks like that. I'll put a link to the Tektronix 147A manual down the bottom here. And it shows you exactly what you need to use to measure these signals and what exactly they do. No linearity is linearity in, say, amplifiers or a transmission system. You can sometimes see the signal kind of get squat at the top or shifted up or down, say, and it causes the signal to get corrupted. So that's what the point of all these test signals are. So we had multi-burst. We have a flat field, which this knob is missing, but all it does is it gives you a flat field. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, or not, it's 100, sorry. It started at 10. It's 50, and 0 again. We have noise, so you can see half line insertion does this. I'm not sure, I didn't read the manual. Pedestal works, noise, there you go. And that's neg 20 dB of noise. If you look at the screen, I don't know, people may remember that back in the day when they had analog satellite transmission, that if they ever lost a satellite transmission, it would look like that, because satellite receiver would insert and frame sync the video, or you'd have a frame sync after the analog satellite demodulator, and then you just see the noise from the satellite, same way as you would on FM radio or AM radio if you're detuned. So it's really cool kind of color noise. You don't see that much anymore at all. We have a field square wave. Looks like that on the wave from a microscope. Looks like that on the TV. Window. Gives you a burst at the beginning and a pedestal. Sin squared pulse and bar. That's what that one is. I'm not exactly sure. That's what it looks like. But anyways, this is composite again. Multi-burst, you can also change between reduced or normal. Kind of looks cool on the screen with that interference. Reminds me of an old 80s computer for some reason. And anyways, that's the Tektronix 147A. Sorry about the camera handiwork here. Just using my phone. Just thought I'd make a short video on this. I replaced all the power supply capacitors in this one, but sometimes it still gives out. So I think it's something else wrong with it. I have extra capacitors replaced. This thing desperately needs capacitors because it takes a while for it to power on and give you a stable signal. So eventually I'll take it apart and do that. The DPS seems to work fine. No issues with that so far. Fan's a bit loud. We'll possibly replace the fan. But other than that, hopefully you enjoyed the video. If you're wondering about any other analog equipment, just put a comment below.